Yung mga na-late na yan, you come early and have your attendance checked before we go. Naglalabasan na naman. Okay, last Monday, we ended up with 3 problems for the application of the formulas for characteristic impedance. So let me reiterate. Characteristic impedance is the impedance of an infinitely long transmission lines. Then, in general, characteristic impedance could be calculated if you know the L or the inductance and the capacitance, no? If you know the inductance and the capacitance. So, but however, if you do not know, then you have to resort to the equation. If you know the voltage as well as the current along the transmission lines, it is also okay. You could also get the characteristic impedance by applying the Ohm's law formula, in which ZO is equals to V Z, or the voltage across the transmission lines, and the current across the transmission lines. Now, if you know the physical dimension of the transmission lines, specifically if the transmission lines is the type in which it is a coaxial cable or a parallel lines, no, or open air transmission lines, or any parallel lines for that matter. So we could calculate the formula for, you could calculate the characteristic impedance applying the 2 equations. Say O is equals to, na-admit ko pa rin. Mr. Balyubar, next time around, hindi na kita tatanggapin. Hindi na sana yung pipindutin ko, napindot ko yung 10:37 na hanggang 10:35 lang dapat. Mr. Balyubar, take note of that. Okay, next. I was saying ZO is equals to 276 times the log of 2S over the D, no? For a coaxial cable, it is 138 over the square root of K times the log of capital D over the D. So, yun ang gagamitin doon sa 3 problems na pinasolve ko sa inyo. Let us see kung sino ang nag-solve. Samora, number 1, anong na-solve mo? What is the diameter of the outer conductor? Samora, JV. Absent ba? Nandito eh. Mr. Samora, where are you? Samora? Wala? So I'll mark you absent today. Wala kayo eh.
Ma'am, pwede po subok. Estrabo po.
Tawag muna tayo na hindi pa natatawag, ha? Yuson.
Yung na-compute ko po, ma'am, ano po, 101.19 po, ma'am.
101.19, anong unit?
Millimeter po, ma'am.
Millimeter, 101.19. Okay. So, tingnan natin ang tamang sagot, no? .77 mm. no? Kasi coaxial cable, kaya ito ang gagamitin mo, no? In case pala guys, in case that it is stipulated in the problem that the dielectric use is air, no? So, or sometimes there is no given dielectric constant. If that is so, it is understood that the dielectric constant is air. Ano? Pag hindi nakalagay yung dielectric constant, na in this case for number 1, siya nga pala, hindi pala nakapresent. Sandali, present lang natin. Yan. In number 1, I was saying that if there is no given dielectric constant, it is understood that the dielectric constant is air. Eh, ano pong gagamitin, ma'am? No? In case na air. The dielectric constant of air is 1. So that, medyo mamomodify na naman ito, mawawala yung square root dun sa ilalim, no? So, dun sa formula, yung square root of the dielectric constant, mawawala kasi square root of 1 is 1. 138 divided by 1 is 1, right? So, magiging ang formula mo is 138 times the log of capital D divided by the small d. Maliwanag? Yan ay kapag hindi binanggit ang dielectric. Kapag hindi iyan, pag binanggit ay hindi air ang dielectric. Minsan, baka yan ang ipahanap sa inyo, no? Kasi maraming, from this equation, no? Maraming pwedeng ipahanap. Pwedeng ipahanap ay CO, direct substitution lahat. Pwedeng ipahanap ay diameter of the outer conductor or given as AO, or the diameter of the diameter of the inner conductor, and you're given the CO and all the others are given, no? So if that is so, ay di ko computein mo na lang. In other words, pwede din ay pa-compute sa iyo ay dielectric constant with all the necessary parameters here given. In the problem presented or that was given to you, however, you are asked for the outer conductor diameter. So you are to compute for capital D, no? So once you have done this, then log of capital D, and the logarithm of division is, ano nga? The logarithm of division is subtraction, right? The logarithm of division is subtraction. So, given, pag nakuha mo to, ilipat mo doon, magiging minus. Then, take the logarithm of capital D minus the logarithm of small d, in which it is given to be 0.584 mm. Then, makukuha mo na si diameter of the outer conductor. Inner diameter of the outer conductor. No? So, the answer is 3.77 millimeters. Masyadong malaki yung 100 plus na na-compute ni Mr. Yuson. No? So, baka nagkamali siya dyan. May pinagkamalian si Mr. Yuson. Square root ito, ano? I-square root mo yung 2.23. Questions so far, guys? Questions so far? Wala. Kayang-kaya nyo na yan. Engineering student eh. Pag hindi marunong mag-manipulate ng formula, siya, wag na kayo mag-engineering.
Okay, ma'am, pwede ba
Yes.
yan, 3.78?
Ano bang kasunod ng 3, 7, etc.? Anong kasunod? Baldinor. Mr. Baldinor.
Wait lang, ma'am. Compute.
Usapan natin 2 decimal places.
Po, ma'am. 4. 3.7.
3.774, Mr. Felices.
Opo.
7-8, ma'am.
I don't have my computation here now. So, ano bang kasunod? Pag pinerform yung nabanggit kong operation.
Ma'am, exact po, 3.78 for gan po.
3.784. O, di 78. Sigurado?
Opo, ma'am.
The rounding off, guys, the rounding off should be done on the final answer, no? Huwag kayong magra-round off pag hindi pa final answer. I-set nyo lang sa memory ng calculator at pag nagko-compute, nagmo-multiply, nagdi-divide, nag-square root, use the entire number of decimal places, and then ultimately at the final answer, that is the time you have to use only 2 decimal places. So 7, 8 pala. Hello?
Yes, ma'am.
784.
Yes, ma'am.
Okay, so ating palitan 70. Yan, 78 mm. Okay na? So pag yan ang nakuha nyo, ay hindi naman naglalalayo yung sagot mo. Next, we move on to the next, second one. Mr. Villanueva. John, I am calling randomly para yung mga pagka-check ng attendance, lumayas agad, a-absenan ko. O nawala na si Zamora, so absent siya ngayon. Villanueva,
Ma'am, yung answer po ma'am is 47.58.
ano yan? Anong unit? Okay guys, pagka walang unit, mali. No, lalagyan ko yan ng Carabao, tomatoes, kung ano pa
Millimeter
man.
ma'am.
Ha?
Millimeter
Millimeter.
po, ma'am.
Ang tinatanong sa ano is ano tingnan natin. We go back to the problem. Ay, sorry. Ang hinahanap, characteristic impedance. Bakit millimeter naman, no? Calculate the characteristic impedance of a coaxial cable of a coax with the K of 2.3. If the diameter of the inner conductor is 3 mm and the inside diameter of the outer conductor is 10 mm. O anong nangyari, Mr.
Ohms pala ma'am.
Villanueva? Bakit naman naging mm yan?
Ohms pala ma'am. Ohms.
Anong sagot mo?
Ohms
What
po
is
yun
your-
pala ma'am. Na
Ano nga?
lang.
Ilang
Nalito
ohms?
47.58.
47.58. Okay, let us see if you are correct. Ito na yan. 47.58 is correct. Yan. Be mindful of the units you are using. Be mindful of the parameter you are computing. O mga iho, mga iha. Tingnan nyo mabuti kung ano yung kinocompute nyo. Ano? Yan ba ay diameter? Yan ba ay dielectric constant? Definitely, pag ang pinakompute ay dielectric constant, wala yung unit. It is a constant. But nevertheless, pwede naman siyang ipakompute. Ma'am, constant na nga eh. Bakit? Gusto nung nagawa ng problem, yun ang computein mo eh. Di, yun ang computein mo. Di ba? So, ayan. So, again, number 2, unlike number 1, is the direct substitution on this equation, no? Direct substitution on the equation of coaxial cable. O yan. Ma'am, sabi niyo nominally, the characteristic impedance of coaxial cable is 75. Hindi naman, merong 50 ohms. Dalawang klase yan, isang 75, isang 50 ohms. As what you have seen when I introduced the different types of transmission media to you on the first lesson, no? So, ibig sabihin, 47 ito, di malapit dun sa 50 ohms na characteristic impedance ng ng coaxial cable, no? Depende kung anong ginamit na RG, di ba? Okay. Kung ginamit na pangsara. And the third one, direct substitution din to Pag mali ang sagot, di ko naman lalagyan ng minus. Pag tama ang sagot, ay yun ang may plus. Okay, Mr. Magnaye. Absent. Hindi, sorry. Magnaye.
Yes po, ma'am.
Number 3, problem.
Yung sagot ko po, ma'am, 359.008 ohms po.
359.08.
0.08.
Okay. Ohms. Tingnan natin, Mr. Magnaye, if it is correct. .08. Dapat lang, ano? Kasi direct substitution na naman yan. Dito lang sa equation ng open wire transmission lines, no? Okay. So, ayan. Kayo naman, tatlong nagpagkadadali lang eh. Na ano na kayo? Yung iba, hindi alam ang gagawin pa rin. Many are direct substitution. Any questions so far? Hello? Any question? Let me make an announcement before I forget. On Friday or tomorrow, you are with me from 10:30 to 12, then 1:30 to 3. Tama? Hello?
Tama
Yes,
po,
ma'am.
ma'am.
So kahit na nakagawa na ako ng link, ay meron kasing pinapalakad sa akin. So I will not be able to meet you tomorrow. Okay, I will not be able to meet you tomorrow. Pwede ko kayo i-meet. Sorry. I-meet ko kayo ay 10:30 to 12 lang. Doon lang sa research. Methods of research. Pero yung 1:30 pababa, hindi ko na kayo may meet. No? So, ECE 04 lang. I-meet ko kayo ECE 04. Ayos? Hello?
Okay po, ma'am.
Kaintindihan?
Copy po, ma'am.
Okay. So, let me continue then. So, characteristic impedance. Let me introduce another constants, another parameters to be used in the calculations or in the analysis of other transmission lines later, or other things that you should know about transmission lines. So the first one is velocity factor. velocity factor. Yan. Velocity, speed. No? So, ang velocity factor is actually the ratio of the velocity of the signal as it moves on the transmission lines and the velocity of light or the velocity of the radio waves in free space. No? Kasi guys, whenever a signal is propagating on free space, so sa labas, hindi naman kalawakan yun no? Dito lang sa kapaligiran natin, sa atmosphere natin. Pag nagpo-propagate ang signal sa atmosphere, nasusunod yung speed niya na 3 times 10 to the 10th centimeters per second. Nasusunod yung velocity, kasi ang sabi sa free space, the velocity of radio wave is also the same as the velocity of light. No? So, kasing bilis din ng velocity ng light. Kaya lang, pag ang radio waves or ang signal or ang kuryente, isa lang yun ay dumaloy na sa transmission media, bumabagal. Normally, bumabagal. Anong dahilan at bumabagal ang pag-flow or pag-propagate ng signal across the transmission lines? Ang salarin diyan ay ang dielectric o insulation na ginagamit. No? So, nakakapagpabagal sa pag-flow ng signal ang dielectric o dili kaya ay ang insulation na ginamit. Okay? So, ayan ang nakalagay dito. When a wave travels on the transmission lines, it travels through the dielectric and or insulation. Dumadaloy din siya doon, di ba? Hindi naman niya pinipili na doon lang siya sa conductor part. Nararamdaman din niya yung insulation na yan. Take note. Dielectric is another term for insulator. Ang insulator, anong ginagawa sa kuryente? Paano niya ibablock? Doon naman dadaan. In one way or the other, kahit doon sa conductor dadaan. Hindi naman sa insulation dumadaan yung kuryente no? Or yung signal. Doon siya dumadaan sa conductor, but nevertheless, the insulation that is being used also impedes or act on the movement of the signal. So nakikialam din siya sa movement ng signal. And ang talagang ginagawa niya ay, since nakialam, bumabagal yung propagation ng signal along the transmission lines. No? So the slower speed of which it travels on the line is known as velocity factor. No? Typically, the values are 0.82. Ibig sabihin, 82% of the velocity of light. No? In coaxial cable, mas mabagal, 0.66 lang or 66% of the velocity of light. Bakit? Abay, kadami namang insulation sa coaxial cable, di ba? Ang daming insulation. Ilan yung patong-patong na insulating material. So, nangingialam yun sa pag-move ng kuryente. So, kaya mababa 66 lang %. Okay? To continue. Yan. The velocity, kulang ito. The velocity of the signal, the velocity factor cannot be greater than the speed of light. It is usually lower. So ito na yung aking dinefine kanina. Velocity factor is the ratio of the actual propagation velocity of the signal and the speed of light. Ito na siya, equation ito. And velocity factor is very much dependent on the dielectric that is being used, no? So iba-iba ang nagiging velocity factor kasi iba-iba ang insulation na ginagamit. Pwedeng Teflon, pwedeng papel, pwedeng rubber, pwedeng ceramic, ano? So depende sa ginagamit na insulation yung velocity factor. So because the velocity of propagation, VP, is very much affected by the dielectric being used. So BP, velocity of ang velocity factor is BF, no? So VP is the velocity of the signal as it propagates on the line, and the C or VC is the speed of light. Ito na yung sinabi ko. 3 times 10 to the 8 meter per second, 3 times 10 to the 10 centimeters per second. Or, pwede rin computein ang velocity factor from the equation 1 divided by the square root of the dielectric constant. No? So, kasi hindi mo alam, hindi mo masukat, hindi mo kayang sukatin ang velocity actually ng signal as it propagates along the transmission lines. So ang alam mo, maaari ang alam mo ay ang dielectric constant. Kasi ang the dielectric constant, this is already prepared, no? May table na sa coaxial sa cable, sa transmission media, may table na binibigay na nasa libro na kung ano yung ginamit mong dielectric, yun ang meron siyang corresponding dielectric constant. So if you take if you divide 1 by the square root of the dielectric constant, you will be able to get the velocity factor. Question? Wala? O another term. So kanina factor. So alam niyo naman ang factor, ibig sabihin division. Tama? Division. Nag-divide ka ng dalawang parameter sa velocity factor. This time, constant, no? So propagation constant. Yan. Ano ba ang propagation constant? We shall use in a little while the symbol sigma. So propagation constant is a measure of the changes in a sinusoidal electromagnetic wave in terms of amplitude and phase while propagating through a medium. So, walang kinalaman ng propagation constant sa velocity, no? Ito ngayon, ang nagdidikta sa propagation constant is amplitude and phase. Of the signal, ano bang tinutukoy ng amplitude? Ano ba yung tinutukoy ng amplitude? Kasi, dapat alam nyo yung pinagsasasabi dito kasi we are just trying to describe an alternating current or a signal propagating in the transmission lines. So let's say, Mr. David, ano yung alam mo sa amplitude ng signal?
Ma'am, amplitude, ito po yung parang lakas po nung isang signal, ma'am.
Power? Are you
Yes.
referring to power? Ay, amplitude nga, hindi naman power. Hindi rin energy. Amplitude. Wala ka ng idea? So, hindi naman to recitation. Hindi naman siya, hindi naman graded.
Ako, ma'am, try.
Okay. Yes, Mr. Mendoza.
Sa ano po siguro? Sa frequency. Sa positive and negative alternation ng frequency.
Frequency. Di sana frequency na yung sinabi, no? Hindi. Amplitude nga eh. Amplitude of the signal.
Try po, ma'am.
Yes, Miss Mandapat, ikaw ba yon? Okay, so that is what? What is that? Ang tinutukoy nun, ay sige. Sige, Miss Mandapat. Hello, Miss Mandapat. Okay. So, to any layman, dapat layman terms ang alam na alam nyo. Ang tinutukoy niya na yung ilan ba yung voltahe, ilan ba yung kuryente. Sabi mo from the x-axis, di ba? Yung taas ng signal from the x-axis. So, ano ba ang ano bang parameter ng signal ang gusto mong malaman? Kuryente ba? So, ilan yung kuryente niya? Yun yung amplitude. And kung ang parameter na tinutukoy mo ay voltage, no? So, ilan yung voltahe? From the zero lines up to the peak value. Okay? So, amplitude simply refers to the amount of voltage and or current, no? Or current of the wave of the signal propagating. What about the phase? When we speak of the phase of the signal, what are we referring to? I explained this, I think, in modulation encoding techniques. Tingnan natin. Si Mr. Navarro. What do you understand of the phase of a signal?
Try ko po, ma'am. Yung ano, ma'am, yung phase modulation po. Ano po siya, yung pattern po siya ng ano, sa communication signal for transmission po. Tapos, nag-encode po siya ng message signal ng instantaneous space po from carrier wave po.
Mhm. Hindi ba nagbigay pa ako sa inyo ng example nito? Yung nagbigay ako ng X and Y axis. Tapos start yung signal, start yung signal sa positive X axis. Pag umikot siya along the X and Y axis or again along the unicolumn, ano, di ba yun yung tinatawag na phase? So yun yung distansya ng signal with respect to the reference, which is the x-axis. Natatandaan ninyo, before I introduce phase modulation, pinaliwanag ko, nagbigay ako ng para maiintindihan nyo yung tinatawag na phase. No? So, yun yung angle distance noong isang signal habang siya ay nagpo-propagate in the form of circle. No? Yun namang positive and negative alternation, actually 360 degrees yun pag nakompleto. So it could be likened to a circle being moved by the signal, na inikot ng signal. So kung may reference ka na positive x-axis nga, positive x-axis, pag nag-move yung signal in a counterclockwise direction, no? So, gaano kalayo yung signal from the reference, that is what we call the phase. Diba? Nakakalimutan na? Yan. Di ba pwede yung signal ay mag-move, tapos makarating siya sa gitna, sa first quadrant. So, maaaring 45 degrees yung phase niya. Pag umakyat siya sa 12 o'clock or positive y-axis, positive 90 degrees yung phase niya. Okay? So, yun yung angle distance of the signal from a reference. Open times, the reference is the positive x-axis. Diba? Okay, question. Yan. Propagation constant. Ano yan? propagation constant, phase of the signal along a transmission line at a constant time, so that the unit is radian per meter or degrees per meter. Yung pagbabago ng kanyang phase, as it propagates through a medium is called propagation constant. Tama naman, pag ang signal palipat-lipat, syempre, nag-iiba-iba yung kanyang phases, no? From the 0 degree or from the positive x-axis, umiiba-iba yon. Okay? So, yun yung tinatawag na propagation constant. Okay, next question. If you have any question, you may just butt in. Wala naman. After the propagation, ito na. Paano ko computing si propagation constant? Kasi yung tawag dito, velocity factor is calculated by, if you know the velocity of propagation on the transmission lines, you divide it by the speed of light. Anyway, the speed of light is a constant factor, no? You would be able to get the velocity factor. Or if you know the dielectric constant, as I made mention, you may simply use this. Now, for propagation constant, ma'am, constant po yan, di ho ba kinocompute? Kinocompute pa rin, okay? So, we will use this symbol. Anong symbol ba yan? Propagation, Greek symbol, sigma. Okay, sigma is equals to the square root of z and y. Ayan. So, saan ito kinuha? Doon na naman sa equivalent ng electrical equivalent ng transmission lines. Yan yung z, no? Yan yung series impedance of the components in series, and the y is the admittance of the components in parallel. Okay, so that naka-divide yung say sa y. Sa propagation constant, naka-multiply. So substituting this times the g plus j omega c. Again, by changing or rather substituting the ones that we have obtained from the lossless line, substituting it here, we will arrive here, okay? Hindi ko na in-expound, so that propagation constant is equals to attenuation plus JB. Wherein the B is phase shift constant equal to omega over velocity factor times the speed of light. Remember that omega is 2 pi times the frequency. No? So again, you just take note of this. We will be using this in the next equation derivation to come. So for lossless lines, the attenuation is 0. Hence, the propagation constant for a lossless line simply becomes J beta, no? It becomes J beta. Again, we shall use this equation later. Next, now we speak of the length of a transmission lines, no? Kasi minsan, take note of this, the transmission lines may be very long physically, but electrically it is very short. Or the electrically ang haba niya pero maiksi lamang yung physical length. So the two types of transmission line length are physical length, we shall use the letter symbol capital S. And electrical length, we shall use degrees L. degrees is small L, no? So S and degrees L. What is physical length? Ano ba yung physical length? Eh, yan yung actual length ng line. Halimbawa, meron kang transmission lines na 100 metro. Eh di 100 meters is the physical length. The S is 100 meters. Or it is also known as the mechanical length of the line. So kung gaano kahaba, inches, meters, yards, feet, kilometers, yun ang unit ng physical length. Physical length haba talaga, yung haba. Then there is the electrical length. Kaya nga nakalagay degrees L, no? This refers to the length of an electrical conductor in terms of the phase shift o kanina, dito sa taas, introduced by the transmission over the conductor at some frequency. So that physical length is equal, electrical length, degrees L is equals to beta times the S. Okay, take note that beta is omega over velocity factor times C. So, yan. So, pagka inayos natin pala, nilagay natin ay 2 pi f, no? 2 pi f doon sa omega, may magka-cancel dyan. No? Later, i-derive natin yung talagang gagamitin na B, no, o beta. So, for the meantime, degrees L is beta times the S, which is the actual length of the line. Okay? So, let's have some applications. Yan. So, kopya guys. Tingnan natin kung may natutunan. Hello. Copy. Kopya. Ito lang. And try solving now. You still have 15 minutes. Dalawa lang yan.
Ma'am, tanong lang po. Ma'am, pares po yun, ma'am, susol. Ma'am, wala po kayong mic.
Yun nga, try nyo kako. Try.
Sige po. Thank you po.
Okay, hello guys. Done? Ready na? Ilang minutes na ba yan? Hello guys. Done? By the way, for number 2, ang hahanapin ay frequency. No? So, frequency yung hahanapin. Nag-move lang to. Supposedly, yan, calculate the frequency. Then, the velocity of propagation is given to be 65.8%. Here you are asked to calculate for the beta or the phase shift constant. O, tawag na ako, guys. Or volunteer, especially those who have not been called. Hello? Volunteer? Any volunteer?
Ma'am, try
Ma'am, pwede
po.
volunteer.
Valdinor. For number 1.
3.35 degree per inch po.
3.35
5 po.
degree per inch. Si Valdinor yun. Tingnan natin. Parang sumagot to kanina. Hindi. Nung isang araw pa pala. Sige. For number 1, 3.34 degrees per inch. Sabi ni Mr. Valdinor. Number 2,
Ma'am, volunteer po.
Mr. Belen. Frequency.
108 po millihertz.
Frequency? Millihertz?
Ay, millihertz tuloy.
Ano? Kilo, mega, giga?
Mega
Ano
po
naman?
pala. Sorry.
Mega.
Megahertz pala.
Hertz.
Sorry
Okay.
ka.
So, try
Nakalimutan ko.
natin. Try natin. May interruption na naman. Sige, tingnan natin. The answer for number 1. So, you're asked for the beta. Tama. Tama si Mr. Valdinor. 3.35 degrees per inch. Direct substitution lang naman. So, you get a plus there. And, ito yan omega divided by VF C. No? So, omega is 2 pi f or 2 pi is 360 degrees. Tama? And the frequency is 110 times 10 to the 6 per second. And then divided by VF1. Yung C is 3 times 10 to the 8 meter per second. Tapos, you have to change the meter into inch, no? So, change natin yung meter sa inch, kaya minultiply ng 3.28 feet per meter times 12 inches per feet. So the answer is, magka-cancel yung magka-cancel dyan, second will cancel. Matitira sa taas ay degrees, matitira sa denominator ay inches. Okay? Maliwanag? Hello? Okay. Next. For number 2. Yan. Ano yung sagot ni 108 megahertz? Sino yung nag-volunteer kanina?
Yes po, ma'am. Belen.
Belen. Si Belen yung nag-volunteer kanina. So, 108 megahertz, no? Hindi millihertz. Megahertz times 10 to the 6. So, ang pinapahanap frequency, given yung sigma, constant, which is 65.8, given din to. So, from the equation, omega or 2 pi f divided by bf times the c, you will get the f, in which it is beta times bfc divided by 2 pi, which is 360 degrees. 2 pi, 360 degrees. So, substituting all the given, 5 degrees per inch, given yon. Kaya lang, tatanggalin natin yung degrees per inch na yan. So, again, i-aanuhin natin. Tawag dito. I-compute. So, yung degrees, i-convert. So, itong 3.28, etc. Para lang ma-convert itong meter na to into inch per second, para yung inch na yon magka-cancel. And then, yung degrees na to, tsaka yung degrees na yon magka-cancel din. Ang lalabas na lang per second. And per second is frequency. So, 108 megahertz ang sagot. Question.
Wala na po, ma'am.
Okay. So, what about the others? Were you able to get? Hello?
Ma'am, pwede po magtanong.
Yes.
Saan po nakuha yung C po? Sa number
C?
1. Opo.
Ikaw naman, constant yun eh. Velocity of light, 3 times 10 to the 8. Kanina ko pa inuulit-ulit. C or VC, sorry sa iba kasi C lang. Sa iba naman VC. Basta nakalagay yung C, velocity of light, 3 times 10 to the 8 meters per second. Or 3 times 10 to the 10 centimeters per second. Diba? Or 186,000 miles per second. So oftentimes we are using meter or centimeter. Mr. Felices. Constant yun. Dapat nandito na yun. Dito kinuha. Okay na.
Salamat po, ma'am.
Others. Wala na? Okay. So, ulit ko. Magmi-meet tayo ay tomorrow ng 10:30 to 12 lang. Okay? So, that will be all for today. You may keep safe everyone. Always keep safe. At baka March, sabi pag nag-level 1, tayo ay mag-face to face na. So sana mag-face to face, we'll see each other para makikita ko habang nagtuturo ako. Latecomers. Colete. Asa na si Colete? Wala. Ligaspi, dumating.
Present, ma'am.
Kasi ito Morbos. Morbos absent. Zamora. Hindi na bumalik. Okay, so absent. Okay, you may now take your leave, guys.
Ma'am Gortesa po, ma'am.
Thank you po, ma'am.